Good morning, everyone. Good morning. Today, that day I've told you that the chapter is finished, but today I felt that some questions we need to discuss from examples. So we're discussing some of the examples today of the same chapter, quadrilaterals. So the same chapter. Good morning, everyone. Good morning, everyone. Good morning. So today some examples we are going to discuss. Out of those examples, the first which we are going to discuss is example number 4. Take out your notebooks and start writing these questions. Yes, write it down. I'm waiting for 1 more minute for the students to join, then we'll start with the class. Yes, and Veer, I have read that. Now look here, example number 4. Two parallel lines. Good morning. Two parallel lines L and M. So there are two parallel lines here. One is line L. One is this line L, and one is this line M. And these two lines are parallel to each other. Fine. So just write given that line L is parallel to line M, and it is being intersected by one line, that is line P, acting as a transversal. Show that quadrilateral formed by bisectors of interior angle. Show that quadrilateral formed by bisectors of interior angles is a rectangle. Means these are given the bisectors of the interior angles. Means this AB, your choice, Aditya. Aditya Jain, whatever you're asking, it's your choice. If you want to, you can. So AB is AB bisect. You can write here that what is given. AB bisect angle PAC. Let's try to understand what is given. This AB is the bisector of angle this PAB, and this BC is the bisector of angle this, and AD is the bisector of angle SAC, and This CD is a bisector of angle ACR. Means these four lines are given bisectors of the respective angles. Manpreet, you can left and come back if it is not audible. So AB bisects PAC, BC bisects QCA. This is all given. I am writing it separately. You can write together also that AB, BC, CD, and DA are bisecting this angle. So CD bisects angle ACR and DA bisects angle SAC. So these bisectors are given. You can send me today beneath. Now concentrate here on this question. So this is given. After that, what we need to prove in this, we have to prove that ABCD, this is a rectangle. So before proving it a rectangle, what we should prove it? Before proving ABCD a rectangle, we should prove it a, yes, a parallelogram. Very good. So we have to prove ABCD first of all a parallelogram, then only we can proceed for rectangle. This is the process as we know. So start with the proving part. So how we can prove this? That ABCD is a parallelogram. Okay, now see this, I am considering it angle 1 and this as angle 2. I am considering this angle as angle 1 and this angle as angle 2. Fine. So just write, since L is parallel to M. See this, this L is parallel to M. Therefore, this angle PAC. Therefore, angle PAC is equal to angle PAC just wait. Manpreet, is it audible now? Now, PAC is equal to angle ACR, alternate interior angles. Angle PAC is equal to angle ACR. See, these two are alternate interior angles because it is making Z. Yes, no? It is making here Z. That's why these are alternate interior angles. If these are alternate interior angles, we can say that half of this will also be equal to half of this. And what is half of PAC? Half of PAC is angle 1 and half of ACR is angle 2. And for that, you can write here reason that AB and CD bisect angle PAC and angle ACR. So AB and BC are bisecting them. That's why half of this will be 1, half of this will be 2. Now just look one more time in the figure. If 1 and 2 are equal, if 1 and 2 are equal, it means this will be parallel to this. See it one more time. If angle 1 and angle 2 are equal, then they are making Z. Yes, no, if the angles are equal, then these lines will be parallel to each other. Very simple. So that's right. That's right. But these are pairs of, these are pair of alternate interior angles. These are pair of alternate interior angles. Therefore, AB is parallel to CD. The way you have proved AB parallel to CD, the way in the same way we can say that BC is also parallel to AD. Just right. Similarly, BC is parallel to AD. Therefore, ABCD is a parallelogram as opposite sides are parallel. If both pairs of opposite sides are parallel, then it is a parallelogram. Now we have proved that ABCD is a parallelogram. Now how we can proceed for rectangle? How we can prove that it is a rectangle? Now see this. This 90 degree is made. This is not 90 degree actually. This is misprinting. Okay, just do not consider this. Now again writing angle PAC and QCA. Just right now angle PAC and ACQ. PAC plus angle ACQ both are making co-interior angles 180 degree. 180 degree because of co-interior angles. So half of PAC plus half of ACQ will be equal to 180 degree. So half of PAC is angle, just see in the figure. The way we have considered this as angle 1 and angle 2, in the same way consider this your angle 3. Write it down in your figure, angle 1, 2 and 3. It should be written there. 1, 3. Okay, now on this basis, half of PAC is angle 1 and half of ACQ is angle 3. This is right. Half of PAC is angle 1 plus half of ACQ is angle 3. For PAC, we have earlier given reason. For ACQ, we can write the reason that BC or CB, we can say CB bisect angle ACQ. CB bisects angle ACQ. Therefore, half of this will be 3. Now 1 plus 3 is 180. Now by angle sum property in triangle, let's come in this triangle ABC. In triangle ABC, angle sum property, if we will apply, no, then we have angle B, and with angle B we have angle 1 plus angle 3. See in the figure, we have angle B, angle 1 and angle 3. So 3 of them will make, sorry, something mistake I have done here. Here it is 180 degree. I have to make it half, because if I am doing half of this and half of this, then half of this also we should do. Just right here 90 degree. because half of this will be 90. Note it down. Half of PAC, half of ACQ. If we are doing here, no, then right side also we have to make half. Then only equations will be equal to each other. Means it will be equal LHS and RHS. So 1 plus 3 is 90. Now in place of 1 plus 3, we are going to write 90 degree. Angle B, 1 plus 3 is 90 is equals to 180. So angle B is equals to 180 minus 90, 90 degree. Now ABCD is a parallelogram. This is an important question. ABCD is a parallelogram whose one angle is 90 degree. Therefore ABCD is a rectangle. This is the full solution of this question. Note it down. We are moving to the next then. Is it done? Example number 5 we have done on Friday. Now we have done example number 4. Now example number 7. Or just let us do first of all example number 8. Okay. Take out example 8 now. In your note, in your books. See example number 8. Page number 149. Read from there. Or wait, let me print example number 8 here. Wait a second. I'm just bringing it here from your book. This is example 8 in your book. L, M, and N. L, M, and N are three parallel lines intersected by transversal P and Q. So there is L, M, and N. These are the three lines which are parallel to each other, and it is intersected by P, a line P and a line Q. So line P and Q are intersecting these three lines respectively. And after that, it is written here that three parallel lines intersected by transversal P and Q such that L, M, and N cut off equal intercepts AB and BC on P. So AB and BC are equal intercepts, equal division. It is written that the line LMN is intersected by P and Q such that AB and BC are equal to each other. These are equal parts. Okay, on this transversal P, it is written there on P. show that LMN cutoff equal intercepts DE and EF on Q also. Means LMN cuts on Q line also DE and EF into two equal parts. Means we have to prove that DE and EF are equal, and here AB and BC are given equal. So what is given? Just write given that line L is parallel to line M is parallel to line N. If language of the question is not clear, then you can ask me. Here equal intercepts means the equal division, means AB and BC are equal to each other. It is given like this. Again, you can read L, M, N are three parallel lines. I have written L, N, M, L, M, and N are three parallel lines intersected by P and Q. Okay, P and Q are intersecting them such that L, M, N on P side is making two equal intercepts AB and BC. And you have to prove that L, M, N on Q side also making DE and EF also equal. So it is given that AB and BC are equal, and you have to prove that DE and EF are equal. That's it. And this type of question you have done in the exercise, which was, I guess, question number 4, like this, or 5. Okay. Now in this triangle, starting with the proving part, see in this triangle A, C, and F. In triangle ACF, in triangle ACF, we can say that BG is parallel to CF. BG is parallel to CF, and reason for this is M is parallel to N. This is given in the question. This is given, no, M is parallel to N. If M is parallel to N, then the part of these lines will be parallel to each other. Very common it is. We have done a lot of times. So in this triangle, BG is parallel to CF, and just write the reason here that M is parallel to N. And one more thing, B is given midpoint of AC. How we can say that B is midpoint of AC? Because AB and CB are equal. Just write another given reason. It is given in the question that AB and BC are equal. If AB and BC are equal and B is the midpoint of AC, then G will also be the midpoint of AF by converse of midpoint theorem. Just write. Therefore, G is midpoint of AF by converse of midpoint theorem. And after writing this, we can say that let us move on to the next triangle. In this triangle AFD, in triangle AFD, now let's move right. In triangle AFD, again G is midpoint of AF. Just see this in this triangle. G is the midpoint of AF. This is right now only we have proved this, that G is the midpoint of AF in this triangle. Now G is also, G and AF are the part of this triangle also, the triangle which we have taken this sky blue. So G is the midpoint of AF and GE is parallel to AD. And what is the reason for this? That L is parallel to M. This is given in the question that L and M are parallel. Three parallel lines were given, no? So L and M are parallel. That's why AD and GE are parallel to each other. Let us write. AD is parallel to GE. Why so? Because L is parallel to M. Therefore, E is midpoint of DF. Therefore, E is midpoint of DF. by converse of midpoint theorem. Again, the same series of steps we have done by converse of midpoint theorem, because here also one is a midpoint and one like parallel line is given. So in this way we can say that E is also the midpoint of DF by converse of midpoint, and with this we can say that DE is equals to EF. Hence proof. This is also proof. Note it down. If any confusion you have in this, you can ask. Giving you 1 minute to write it down. Then we'll move on to example 7. Okay, I'm repeating it again. If you want to understand, no, you can understand only by the help of figure. See this, the diagram. It is given that B is the midpoint of AC. Why? Because AB is equals to CB. You can even see the solution side by side. First of all, we have written that L, M, and N. These three lines are parallel to each other. So L, M, and N are parallel to each other. And after that, AB and BC are equal. AB and BC are equal because it is written here that equal intercepts AB and BC have been made. It means AB and BC are equal. Then we have to prove that it makes it equal intercepts DE and EF. Means we have to prove that DE and EF are equal. This is required to prove DE and EF. So how we can link AB, BC, and DE, EF? There is no link. There is no triangle. So that's why we have to just go into this triangle first. Then this triangle is just connected with the other triangle. So we'll move into the other triangle first then. So starting with this triangle ACF. In triangle ACF, B is the midpoint of AC and BG is parallel to CF. As these three lines are given parallel, so BG is parallel to CF. That's why by converse of midpoint, we can say that G is also the midpoint of AF. Now come in this triangle. If G is the midpoint of this and GE is parallel to AD, then E is also the midpoint of FD by converse of midpoint. So it is proved. It is very easy. And the same question we have done in exercise also. The main thing is the same type of question we have done in exercise. That was question number 4. It is also like that. Trapezium is made here. A, D, F, C. Like that. It is just like question number 4. If you will see the proving part, it is also like this. Okay. Moving on to example 7. So let me print example 7 here. So it is example 7. In triangle DABC, so we have a triangle ABC here. Okay, Dhruv, you can see from here the last part if you have not written. Write it down if it is left. Say it is your choice. Is it done, Dhruv? I guess it is done now. Okay, okay, fine. So question, example number 7 now. In triangle ABC, DEF are the midpoints. Writing given D, E, F are midpoints of AB BC and CA. CD is the midpoint of AB, E is the midpoint of BC, and F is the midpoint of CA. After that, show that ABC is divided into 4 congruent triangles by joining DEF. Okay, so to prove that here no 4 triangles you are able to see. CEF, these small triangles, CEF, DEF, ADF, and BED. These 4 triangles should be congruent to each other. This is written here. So triangle DEF congruent to triangle ADF is congruent to triangle BED is congruent to triangle CEF. So how we can prove this? Proof. Nothing else is given in the question. Only the midpoints are given, and we have to prove these 4 triangles are congruent to each other. See, we have only midpoint theorem which we can use in this, as midpoints are given. Consider this triangle ABC. Just write in triangle ABC. Just see the full triangle ABC and write D and F are midpoints of AB and AC. D is the midpoint of AB and F is the midpoint of AC. If D and F are the midpoint of AB and AC, then DF is parallel to BC and DF is half of BC. So we can write that by midpoint theorem, DF is parallel to BC and DF is half of BC. And can we say that half of BC is BE? Yes, why not? Because E is the midpoint of BC. This is already given. So we can write here that here half of BC means BE because E is midpoint of BC. Just see in the figure, E is the midpoint of BC. Therefore, half of BC means half of this full BC is BE. Or you can write EC also. This is your choice. If you want to write EC, write EC. You can go by that also. You can go by this also. So I am writing right now BE. So, and with this we can write that DF is parallel to BC. So DF is parallel to BE also because BE is the part of BC. If one pair of opposite side is equal and parallel, see this. If one pair of opposite side is equal and parallel, then it is a parallelogram. In this way, BEFD is a parallelogram. Therefore, BEFD is a parallelogram since one pair of opposite sides is equal and parallel. If one pair of opposite sides is equal and parallel, we can say that it is a parallelogram. Similarly, we can write here similarly like this, all are parallelograms here. The way we have proved this, no, BEFD is a parallelogram. In the same way, CEDF, this CEDF is also a parallelogram. So similarly, CEDF, and we have one more parallelogram here, ADEF. ADEF. CEDF and ADEF are parallelograms. Just write similarly and write this because we can't prove no again and again the same thing. It is wastage of time. So in this way, all of these are parallelogram. BEFD, CEDF, and ADEF all are parallelogram. Fine now. Now just write since diagonal, there is a theorem. Diagonal of parallelogram divides it into two congruent triangles. diagonal of parallelogram divides it into two congruent triangles. Always a diagonal of a parallelogram divides the parallelogram into two triangles and which will be congruent to each other. Therefore in parallelogram BEFD, just take the first parallelogram now. In parallelogram BEFD, you see this in parallelogram BEFD, what is the diagonal? Where is the diagonal? DE. DE is the diagonal, therefore this and this triangle are congruent. So DEF and DEF and BED are congruent to each other. Okay, and here what is the diagonal? DE is the diagonal. We have written here the theorem one time, so we are not going to write again and again. Just mention here the D is the diagonal. So the diagonal has divided the parallelogram into two congruent triangles. So we can write similarly. So similarly in parallelogram CEDF, so see now CEDF, we can write even here parallelogram CEDF. In parallelogram CEDF, EF is a diagonal, so DEF and CEF are congruent. So triangle DEF is congruent to triangle, what was that, CEF, make it second. Similarly in parallelogram ADEF, triangle DEF is congruent to triangle ADF. From first, second and third, we can say, see this DEF is common in all. So with the help of DEF, we can say that these all four triangles are congruent to each other. Therefore, triangle DEF is congruent to triangle BED. Just write all the triangles together now. Congruent to triangle CEF. So this is done, and the chapter is finally over with the help with examples also. So these were some important examples so we have discussed today. So DEF is there in the LHS. So DEF I have took one time, and all these write one. BED, CEF, and ADF I have written. Just note it down. And it is over. Tomorrow, no, just get ready with geometry, because tomorrow we are going to start chapter number 11, construction, and try to understand the chapter very carefully in online class. Yes, those who have not sent me the notebook in PDF form of chapter 8, they can send me now, and I have maintained the record. Those who have sent me the notebooks, I am going to give them full. Okay, those who are not sending me, just consider it zero. Just tell your friends also if you have not sent me the notebook. Okay, bye, take care.